Gravity is a force. To solve the mystery of gravity, we must first understand what force actually is and how it came to be. Force is one of the most important factors in physics. Until we have a clear explanation of what force is and how it arises, the validity of many physical theories remains in question. Today's physical understanding of force is based on Newton's law of gravitation. According to this law, every point mass exerts an attractive force on every other point mass. That is a serious mistake in physics. This law leads the entire field of physics astray. In fact, matter is a neutral object that neither exerts a force nor can be converted into energy. And it certainly possesses no supernatural abilities. Newton's second law states that the velocity of an object changes under the influence of a force. Simply put, the motion of an object arises from the action of forces. Of course, this equation also applies in reverse. So does that mean that a change in an object's velocity generates a force? For example, when the velocity of a flying cannonball is slowed by air resistance, acceleration occurs in the opposite direction, creating a negative force. This negative force is caused by air resistance, and a force F acts on the cannonball itself in the direction of motion. From this example, we can conclude that a force is generated when the velocity of a moving object is impeded. For example, when a boxer strikes his opponent's head with his fist, a force is generated that can knock the opponent to the ground. However, if the opponent's head moves backward at the same speed, the fist's velocity is not slowed down, even though it makes contact with the head. In this case, the fist generates no force other than a rapid movement. A person jumping from a tall building is in free fall under the influence of Earth's gravitational pull. Their motion is not slowed, they are in a state of weightlessness and do not generate any force. A person standing on the ground, on the other hand, exerts a gravitational force on the ground, since their original outward motion is impeded by the ground, thereby creating a gravitational force. Similarly, an object in circular motion generates a centrifugal force, since its original outward motion is impeded by the centripetal force. Newton defined the magnitude of a force as follows: the force required to accelerate a body with a mass of 1 kg at a rate of 1 meter per second squared is 1 Newton. We can also interpret Newton's second law in reverse: the resistive force required to reduce an object's velocity by 1 meter per second squared is 1 Newton. In that case, the object generates a force of equal magnitude but opposite direction. This means that when the object's velocity is impeded, a force is generated. In other words, force arises from the motion of a massive body. If we substitute this principle, namely, that force arises from the motion of a body, for Newton's statement every point exerts a force of attraction on every other point, then we set physics, which is currently on the wrong path, back on the right track. Does gravity then also arise in the same way? Two people standing on a turntable and connected by a rope attract each other with their respective centrifugal forces when the turntable rotates. At that moment, both sides exert a pulling force on the other. Undoubtedly, this pulling force arises from the mutual centrifugal force generated by the rotational motion of both sides. Let's compare this to two celestial bodies orbiting each other. Here, too, the centrifugal force between them undoubtedly generates a mutual force of attraction. Is there a certain connection between this mutual centrifugal force and gravity?